Hello again, welcome to another video. In this video, I'm going to kind of summarize all the important things about using sigma notation and factorial because we're going to see them a lot in calculus 2, especially when we get into series. So let's go and see how can we use them and what are they. Basically, sigma notation is the little e sign, like this one right here, is used for summation, and it consists of two limits. The lower bound shows us where to start and the upper bound shows where to end. Plus, there is a rule here, which is kind of the formula for the sequence and for the term itself. So let's see what is it and how can we use it. For instance, this one means that add the terms, like plug the terms starting from 1 up to n and plug it into this rule right here. So this represents like the rule, like what I'm going to do with I, the iterative I. So I'm going to write it, start from 1, so basically it's going to be 1 plus 2 plus 3 plus up to I get into n and I stop there. Let's see an example. I from 2 up to 6 of I. This would be what? Plug this one right here into the rule, so it would be 2, add 1 and 1 until you get to 6. So basically it's going to be 2 plus 3 plus 4 plus 5 plus 6. This is what it is. Let's see another example. This one right here, 2i minus 2, is starting from 3 up to 5. This would be what? This would be replace or kinda plug the iterative I into this one and add 1 to that until you get to the upper bound, which is 5. So it's going to be 2 times starting from 3 minus 2 plus 2, add this one by 1, so it's going to be 4 minus 2 plus 2 times 5 minus 2. And I stop here because the upper bound is 5. And I'm going to calculate that and see how much it's going to be. And that would be the answer to the sigma notation. But let's get back into here and assume that instead of 2, this was starting from 1 up to 10. This would be 1 plus 2 plus 3, 4, 5, 6, 7, 8, 9, 10. I wrote all of them because I'm going to show you a pattern. If you notice right here, if I add the first term with the last one, this one with this one, I'm going to get 11. If I do the second one with this one, I'm going to get also 11. If I get this one with this one right here, also I'm going to get 11. So how can I find the sum? Well, I have 11 right here, but how many 11s I have? It's going to be basically this one and this one. So it's going to be 1. I have this one and this one. It's going to be 2, 3, this one and this one, 4, this one and this one, 5. So 11 times 5 going to give me 55. And instead of just doing this all the time, I have a formula, n times n plus 1 divided by 2, which this would be what? My n is the upper bound, which is 10. So I'm going to replace n with 10. So it's going to be 10 times 10 plus 1, which is 11, divided by 2. 10 divided by 2 is 5. So it's going to be 5 times 11, which is 55, the same as this one. So now I know that I can rewrite this sigma notation right here as n times n plus 1 divided by 2. We have another example, which is the constant one. This one. This constant one basically says that multiply the n into the constant number. Let's see an example. If I have the sigma notation I from 1 up to, like, say 5, and this is 3, this would be what? Plug this one into this one and increase it by 1 until you get to the upper bound. So let's do it. If I plug I into this one, it's going to give me 3. This is for 1. This is for 2. This is for 3. This is for 5. And this is for 5. And I stop here because the upper bound is 5. So this would be what? This would be 15. And this is the same as multiplying this 3 into this n, the upper bound, which is going to be 5 times 3, which gives me 15. So now I know that I can rewrite the sigma notation, the constant sigma notation, into this one. And I can find the summation of this. In the last one, I have the squared one. Let's see an example. I starting from 1 up to, say, 5 of I squared. So basically plug the iterative into the rule up to 5. So basically it's going to be 1 squared, which is 1, plus 2 squared, which is 4, 3 squared, 9, 4 squared, 16, 5 squared, which is 25. I'm going to stop here because I reached the upper bound. I'm going to find the sum. The sum is going to be 30, 39, 45, 55 it's going to be. And I can find the sum from this formula, which is n was 5 times 5 plus 1, which is 6, times 2 times 5, which is 10 plus 1, 11, times 6. So 6 with 6 cancels out. 5 times 11, 55. So now I can rewrite this one with this one right here. Sorry about this one. I just wanted to, write as this one. So these were the most important thing about using sigma notations, and what are they equal to, and how can we find the sum of them. Like, instead of doing the like the summation just manually one by one and write the sequences term by term, so we use the general form, which is this one, and for the degree 1 we use this one right here. Let's get into factorials. What is factorial? Factorial is the product of all natural numbers from 1 up to n. So if I have n factorial, this means 1 times 2 times 3 times 4 up to n. Let's see an example. If I have 7 factorials, I can write it as 7 times 6 times 5 times 4, 3, 2, 1. But the most important thing about factorials is just to notice that I can rewrite 7 factorial as 7 times 6 factorial. Or I can rewrite it as 7 times 6 times 5 factorial. Or I can write it as 7 times 6 times 5 times 4 factorial, and so on and so forth. So yeah, this was another thing about factorial, because we're going to do this a lot, especially when we get into a series. Or as a general form, if you have something like n plus 2 factorials, you can rewrite this as n plus 2 times n plus 1 times n factorial. And this is the general form of doing the same thing, but in terms of n. This was everything about these two important things, because we're going to use them a lot, and it was a good idea just to have a background about them. We'll see you next video.